And let's see how we can use GP to solve it. So there's two people, David and William, toss a coin alternately, beginning with David. The first tossed heads wins. What is the probability? What probability of winning does David have? So let's draw a tree diagram. So David gets to go first. So David will toss a coin. The outcomes are either head or tail. And if David gets a head, he will win. But if not, William gets to toss the coin. Okay? And William will have 1 in 2 chance of winning after David toss, right? And if William gets a head, William will win. Otherwise, David will get to the next toss. And the game just continues indefinitely. If no one gets ahead, you just keep continuing. W for William. H and T, right? And just so forth. So what's your chance of David winning? So you write probability David wins. David wins. Okay, now on the branch you can write half and half, half and half, half and half, 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 right? But you don't have to label because you know it's going to be half if you know it's all half. Okay, good. So what you do is for David will win, you either get the head as your first toss, right? Or that means if David wins, he could win on the second toss. That means both David and William gets a tail, and then on the third toss, David gets a head. Does that make sense? Or it could be, let's do it one more time, that's David's turn, head or tail. Or David could win on the fifth toss, where David goes first, gets a tail, William gets a tail, and then David gets a tail again, William gets a tail, but on the fifth toss, David wins, etc. So we want to find the probability of winning. So that means for the first probability is half. For the second probability, you just go half times half times half for this. Half times half times half. Get the idea how I use the tree diagram to get the answer? Or the next one is half times half times half 5 times. Right? Plus dot dot dot. Depending on which toss David gets ahead. But we have to include all the possibilities. And if you write this as a series, it looks like it is a GP, isn't it? Alright, why is it a GP? Because the next term is generated by multiplying by half square, right? That's your common ratio. Every time to get to the next term, it times by half square. And that's true, because to get for the next win, both of them have to get a tail before you get a head, right? So that's why you get the common ratio of half square. And the first term is half. And because the series never finish, it will be a limiting sum. And it will be limiting sum because the common ratio, which is 0.25, has to be less than 1. Remember the condition for limiting sum to exist? That the common ratio has to be less than 1, or between -1. And it is less than 1. Okay, so therefore we're allowed to use the formula. So you go first term over 1 minus half square. And then use your calculator. So let's use the calculator. You get fraction. Now, instead of typing half, I like to type 0.5. It's much quicker to type. Minus 0.5 square. Yep. You get, well, and then the answer, you should write it as a fraction because it's non-terminating, 2/3. So David has a slightly higher chance of winning. So David wins will be 2/3. What's the chance William will win? Must be the complement, isn't it? Yeah. Alright, so watch out for these questions where you get GP in your probability. Okay? Some HSC question can ask that in some of the harder questions towards the end of the exam paper. Okay, good. And then we'll do another hard question, which I got from a trial exam paper, which is also quite interesting. Let's have a look. Okay, hopefully you're all ready. Let's try this. Let's go to the next page about tennis match. Okay, so Nadine is playing a tennis competition. She is required to play 4 matches, and she must win all 4 matches to win the competition. She has a 30% chance of winning the entire competition. And each match, her probability of winning decreases by 5% of the preceding match. What's your chance that she'll win the first match? Okay, so if I were to draw the tree diagram, you either win the first match or lose the first match. But we don't know the chance of winning the first match. So what we do is we have to use pronumeral. Let's say the probability of winning the first match. Let's write it here. Let the probability of winning the first match. Winning the first match be P. Okay, so we're going to write P, and the chance of not winning will be 1 minus P. Okay. All right, so we did that. And she must win all 4 competitions to win the match. So if you lost the first one, she won't win the whole match, so she will just be eliminated, I think. So you just write win again. But your next chance of winning will not be P. It will be 5% less. So it will be 95% of the preceding match. Does that make sense? Not 5%, because decrease by 5% means you still have 95% of your chance of winning from before. All right? That's for the second match. And then we'll proceed to get to the third match. The third match will be 95% of the previous. So you go 95% square, right? Because you have to time 95% of the previous match, P. And to win the last match, it will be even 5% less. So it will be 95%, 95% of P cubed. Okay? Alright, so we've got this tree diagram. And your chance of winning the entire competition, means that you have to go probability of winning all 4 matches. And your chance of winning all 4 matches must involve multiplying all the probability together so you have to times them all together. So that equals P multiplied by 95% of P times 95% square of P times 95% cube of P. And then you times them all together, you get, what do you get? You get 95% to the power of 6, right? Because it's 1, 2 plus 2 plus 3, you get 6. P to the power of 4. And then we're going to solve for P. Now, how do we know? Because your chance of winning the entire competition is 30% of winning the competition. So now we have an equation. And to make things easier, I will just use decimal. 0.95 power 6. So it's easier to write. So to work out what P is, you go 0.3 divided by 0.96 power 6. Right? And you fourth root your answer. 0.3 over 0.96 to the power of 6. Use your calculator, you will get square root of fourth root. So how do you do fourth root? Use this button, put a 4 there, and then put fraction 0.3 over 0.96 to the power of 6. 95. Oh, don't know why. Okay. Okay, sorry, I will change that. Okay, good. So let's continue. Change that to 5. Okay, good. All right, so press equal. So she actually had a very high chance of winning the first match, 0.8%, isn't it? So 79.9. Which is 79.92% of winning the first competition, the first match. But to win the entire competition, it will be much lower because it's much harder. So you can win the first match at a very high chance, but to win the whole competition, you have a very low chance of winning. Okay. And then some HSC questions I'm going to go through with you from various years. They are a little bit challenging. So we're going to do 4 HSC questions. Okay. All right. Let's do that. All right. Hopefully all done. All right. So we go to the next page. All right. HSC questions. Let's look at this one. See if you can solve it. It's asked in the second last question of the exam paper, 2009, question 9A. Okay, let's look at this. Each week, Van and Marie take part in a raffle at their respective workplaces. The probability that Van wins a prize in his raffle is 1 over 9. The probability that Marie wins a prize is 1 over 16. What is the probability that during the next 3 weeks, at least one of them wins a prize? So 1 mark, 2 mark question. Right, have a think. What would you do? So at least one of them wins the prize. See, when you see the word at least, you should have a bell ringing in your head that must be hinting you to use something. What should we use? Complementary. So we do the complementary. At least one means 1 minus what? Wins what? So at least one win, one of them has to win. What's the complementary to it? No one wins. Very good. No one wins. Specifically, no one wins for 3 weeks. So what do you do? That's not very hard. You don't even need a tree diagram. So if they don't win for 3 weeks, means Marie will be the complement. Instead of 1 over 9, will be 8 over 9 for not winning for 3 weeks. Right, to power 3. And Marie will be not winning for 3 weeks. And you multiply them together. Get the idea? So look out for the word at least. Yep, okay, use your calculator. Let's see. So what's the chance of winning at least one prize? I think it will be pretty high. So you will probably win something in 3 weeks. So you go 8 over 9 to the power of 3 times 15 over, oops, Great. Okay, good. What do you get? 91 over 216. Not very high, but not very low. Yep, got it. Okay, good. Let's try another one. Have a read. The next one is a little bit longer. This is more recent. 2011, question 5. Have a read, okay? Give it a few minutes. You should try to solve it yourself. Think about it. Try to think and see if your thinking matches my thinking. Okay, go. I'll have a try, give you about maybe a couple minutes. So the first part I think is pretty easy, probably where's a red shot on Monday. So there's 3 red, 2 yellow. So it'll be 3 out of 5. Should be right. Okay, good. Next one, probably wears a shirt of the same color on all 3 days. So as you can see, you can't have yellow on all 3 days. It has to be red all 3 days. So you probably don't need a tree diagram because it's going to be R, 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 right, when you draw it. So what you do is, it's going to be red on the first day. Now remember, it's no replacement. It will be 2 out of 4 on the next day for red, and 1 out of 3 on the third day. And you times them all together. Get the idea? And then if you use your calculator, or you can do it by hand. Cancel, that's a half. So you get 1 out of 10. You all got that? Good. Okay, so that's good. Now the next one's a bit tricky. I think you probably have to draw a tree diagram for that. Does not wear a shirt of the same color. Now, would it be using the complementary probability to 2? The answer is no, because they say consecutive days. It doesn't have to be all 3 days, just consecutive days. So just have to make sure you wear it on at least 2 days that follow each other. So let's draw it. Got red, yellow. That's on Monday, right? So now even for 1 mark, you probably have to do a lot of work. So that's the nature of the question. So the last mark are usually very hard to get. So, but if you can't get it, you won't lose too much mark, which is good. But if you get it, you get 1 extra mark, which can put you in a better position. Okay. All right, let me see. Red. Oh, let me get that. Okay, good. Let's continue. Red, yellow. And then red, yellow. And that finishes. And then red, yellow. Red, yellow. Red, yellow. All right, so which one are consecutive? It has to be RRR, or can't be, or, and then it could be R, yellow, yellow. Can be this, can be that. Or can be this as well, RR, yellow, right? So that's correct. And YRR, or YY. Now, as you count this, you see there's a lot of probability to add. So therefore, it will be better to do complementary. So which one I didn't do? 1 minus probability of RYR and Y. Yeah, you just have to make sure they wear different shirt, right? Oh, does not wear a shirt of the same color. Oh, sorry. I shouldn't look at this. So the only thing I have different color. Sorry, I did it too complicated. Whoops. Now let's get rid of the 1. So you only have to be different. Yeah, so there's only 2 ways, RYR or YRY. Okay, so I have to read the question carefully. Okay, so let's put this up. Okay, let's try that. So what would that be? So that will be, red will be 3 out of 5, 2 out of 4, 2 out of 3, plus yellow is 2 out of 5, 3 out of 4, 1 out of 4. And then use your calculator. So you get 6 over 60 plus, that should be a 3. 60, 12 over 60. Do you get 1/5? Is 1/5 the answer? Last. 12, is it? Alright, so I have to check my working. Oh no, hang on, that's not 6. 12, that's a 12. So I get 18. So 18 divided by, so divide by 6, you get 10, divided by 6, you get 3. 3 over 10? 3 over 10. Okay, good. Alright, that's it, good. Well done. Alright, next page. What's the next one? I haven't tried the next one about die. Okay, so they come in a variety of forms, probability. So would you make this a hard topic to do in the test? So you just have to read the question very carefully. Sorry, I have to pick up a call. Alright, was it still recording? Alright, doesn't matter. Okay, yeah, break. The tables to list the outcomes. So try to draw a table, or you don't have to draw a table, but you know there will be 36 outcomes altogether, and find which outcome will result in the score of 0. Okay, think about it. Let's continue. So there are 36 outcomes. So when you draw the table, you have 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. So it's just like a multiplication table. If you times them, everything here will be 0. Everything here will be 0. So how many 0 are there? There will be exactly 11. So 11 out of 36. So you get a score of 0. Part 2. What's probably scoring 16 or more on the first turn? So again, you don't have to fill out everything. How do I get a 16? It's going to be 4 times 4, which is 16. And there's no other way, because 16 is 2 times 8. There's no 8. Oh, but you say 16 or more. So that's the tricky bit. Okay, so 16 or more, so it'll be 5 times 4 is 20. 6 times 4 is 24. Oh, that's why I have too many. I feel very, okay. So there's no 24. All right, okay, so that makes it easy. So therefore, only these numbers, 20 and 25. Right? So it'll be 4 out of 36. Agree? Everyone got that? 4 out of 36? Okay. The next one gets tricky because you have to do 2 turns. You have to throw your dice, 2 dice twice, so that the sum of the score is less than 45. Okay. Let's see how we can get 45. So you probably have to get some more numbers, but I think it's related to part 2. So let's look at the numbers. The numbers are less than 45. Okay, so some are 15 here. That's 15. I think these are pretty small. Okay, good. All right, so probability sum less than 45. That's a lot of numbers to look at, so a better way will be doing the complementary, that being more than or equal to. More than or equal to 45. Yes? And what do you get? More than or equal to 45. So what you're going to do, so what will 45 be? So how do I get sum of 45? So 45 can only be using 2 numbers. So how do I get 45? 45 is either, actually more than 45. Let's write more than 45. Bigger than 45 could be 25 plus 25. 20 plus 25, and that's it, right? And you have to look at different order. Okay, so let's categorize it into tosses. Sorry, so first toss you get a score of 25. Second toss, 25. Yeah, you can get a score more than 45. Or your first toss is 20, second toss 25, or first toss 25, second toss 20. Does that make sense? These are two different outcomes, depending on which one is the first toss. So that gives you 50, that gives you 45, that gives you 45. Are there any other ways? That's all right. Okay, so let's find a chance of getting 25. All right, let's find the probability of getting 25. To get 25, what do? You have to go, oh, there's only one way, right? 1 out of 36. The probability of getting 20, a bit more tricky, because there's two different ways to get 20, right? So it'll be 2 out of 36, which is 1 over 18. So now, to answer this question, probability of more than 45, which is equal to probability of 25 and 25 plus 20 and 25 plus 25 and 20, right? And to get the probability of 25 and 25, you need to go 1 out of 36 times 1 out of 36. To get 20 and 25, you get 1 out of 18 times 1 out of 36 plus 25 will be 1 out of 36 times 1 out of 18. Yes, okay. Let's do it on a calculator. So you can do, do you know what's a better way? Let's not simplify it. Let's keep it as 2 out of 36 because they will have the same denominator. So you get 1 plus 2 plus 2, 5 square, 36 square. Yes? So therefore your chance of less than 45 without equal to will be equal to 1 minus probability of more than or equal to 45, which is a very small chance that will happen, or a very high chance. So it will be 1 minus 5 to the over 36 square. 1291. 1291 over, hopefully I didn't get it wrong, 1296. Okay, done. Okay, hopefully done. So it can be very difficult for 2 marks. It can be very difficult, very tricky. All right, we've got 2 more questions to do. One more HSC paper. Have a read about cards, and then you will do some HSC questions for homework. And you can start to do that in class. Have a try. I know it's exhausting, but okay, continuing. Next page. So it's a question about the card. So who did the first one? So anyone want to explain? So hopefully you have a read. So you want to make sure your chance of getting your second card is different from the first. So what would that be? Yep, or, yep, so, sorry. Yeah, what is 13 out of 52? Yep. Yep. Very good, yep. Okay, but why is it, that's when you choose, maybe you chose heart, right? And this one could be any of these not heart. But are there any other possibilities? You can choose maybe spade first, and then not spade. Agree? So you have to look at other possibility as well. So that's a good way of doing. So what do you have to do? You have to go, you have to look at other possibility. Right? So you can start with heart, not heart, or spade, not spade, or what's the other shoe? Spade and club and diamond, right? So you have to do it all 4 times. Okay, all right, good. So that's a diamond. So what do you get? What do you get? You get, oh, so basically whatever answer you got, just multiply by 4, right? And what would that be? So just get 13 out, so it'll be 12 over 13. What do you get? So divide by 3, you get 13 out of 17, right? So what's a faster way? Let me show you a faster way, method 2. Method 2. Method 2, watching. To get method 2, instead of doing this all 4 by 4 cases, your first card could be anything. So I just go 52 over 52, right? Your first card could be any card from the suit, but your next card has to be different from the first. Therefore, just go 39 out of 51. You should get the same answer, right? So the first card could be anything. The second card has to be different. So you don't have to do all 4 cases. All right, good. All right, good try. Okay, how about the next one? All 4 cards are different. You can select 4 cards without replacement. It's going to be very similar. See if you can work out. So you got it? It's very similar to the first, to this method. Method 2. Use method 2. It's going to be very easy. Okay, good. So what you do is 52. All right, so what would it be? 52 over 52 as your first card. Your second card will be 51 cards left. So 39 out of 51. But the next card will be 2 suits left. Will be 26 out of 50. And the next one will be 1 more suit left. Let's see what you get. So it's going to be 13 out of 17 times by fraction, 26 over 50 times by fraction, 13 out of 49. Yeah, that big number, 2197 over 20825. Done. All right, I think we've done them all. There's some other question we skipped, but I don't think they're that important. Okay, so that's it. We'll finish. All right. So can you try the HSC question today? I'll see if I could find the answers. And thank you.